Welcome, everybody. Thanks for showing up on time here on a Sunday. I want this to be as engaging as possible, so feel free to fire away questions. I know sometimes I'll talk a little fast, but definitely slow me down and want to answer any questions you have. Um, and yeah, a little bit about myself before we jump in. I've been a full-time GMAT expert and teacher since 2016, and this will be my second year teaching TTP group class. So we do have another cohort coming up. This will be my sixth one coming up on Wednesday, May 29th. I'll drop it in the chat here, the LiveTeach link, and that one will be Mondays and Wednesdays, 8 p.m. Eastern. So we'd love to see you there. And yeah, really looking forward to it. It's been a lot of fun. Love to make it as fun and engaging, like I said, as possible. Help everyone overcome their challenges. So yeah, look forward to your questions today. We're going to be doing practice questions for you, as well as trying to cover as much as we can here on graphs. And yeah, so for data insights, it is incorporating a lot of the skills that we learned on Quant and Verbal. So it is okay today if some of it's a bit challenging for you. You will, in the course, be covering a lot of that other stuff first, percent change, ratios, reading things carefully. That's the biggest one to prevent mistakes. Yeah, let's jump in. So a huge thing for graphs and data insights in general, and partly why the accuracy levels are so much lower on data insights, is you do not get partial credit. So suppose we're at 80% accuracy and we have a three-part question. That's going to drag us down to only 50% overall, or a two-part question that would be like 64% accuracy. So there's going to be a huge difference there. If you're probably going to be like, I was doing a little bit of math. It can vary a lot based on difficulty of questions, but if you're at like 70% accuracy, that'd often be like maybe an 82 overall, which is like a 94 percentile. Whereas, you know, if you're only 70% accurate on each part and you have two parts, that drags you down to 50%. It's going to drag you down a lot more. So as throughout all the test, the biggest thing is like preventing those careless errors, rereading things, double checking what it's asking for. And we'll see an example today where it's just as simple as counting drags people's accuracy down to like 34%, kind of just from miscounting or misreading the graph. So it's a great way to pick up points. One little tip that I love on this, and I take the test a lot myself, taking it 5 times, is like try to practice what I preach. Is I notice that if I'm in a kind of a lazy mindset, lazy body language, that can really drag down my accuracy. So one tip that I got from Chess Pros is just leaning a little bit forward can make a big difference in your attentiveness. Deep breathing as well, like before you start. The mantras, some of my favorite are sharp, focus, precise. Also, I'm totally dialed in. I think that's a really great one. Yeah, I was just reading this book, Mental Toughness Training for Sports. Really good. And a lot of that stuff you apply to other aspects of your life. See if you can channel that and even create your own mantras as you're tackling the GMAT. But let's get into this. That just wanted to make that really important thing that people are like, oh man, like I got 2 parts out of 3 correct and just barely missed that last part, right? And it is pretty painful. So yeah, we really want to do our best to do everything possible for that vigilance and mindfulness and proactive prevention, whatever habits we can do to proactively prevent errors. But let's get the screen share going here. So this was just talking about no partial credit. Here's a very basic example we'll start with. So you have this graph. Again, being really mindful. Ratio of number of bagels sold on Tuesday to Friday. I cringed really hard the practice test I took a few months ago where I checked every single step but didn't check, right? A very common one to mix up is what order the ratio is in. We need Tuesday to Friday. This is an easier question, so it doesn't have this trap here, but it is a really common trap to get it backwards. So we got Tuesday here. We just read on the graph 120, and we got Friday here, the 180, reading carefully. So we got a 120 to 180. And we have a 2 to 3. And so that's 2 to 3 there. And I'll let you try the next part. I'll get the poll up here, 1 sec. And I may push the pace a little bit today, but just do your best in the short time we give you so we can cover more. All right, and if you, just throughout today, you can also put into the private chat if you want to drop in your answer a little bit after the timer expires, that's fine. So that's a little tough on time, and maybe you haven't covered as much on percent change. But what we're going to do here, we look on Wednesday. All right, we got Wednesday as 140. So we'll say, and then this is 40% greater. So you take the Wednesday, we write 140 is equals 40% greater. So it's 1 plus 40 over 100 is the formula, or just shortcutting it to 1.4. If you're more comfortable with it, equals 1.4, whatever the other day is. Potentially some of you will just kind of see it on the graph, the 40% less, or if we worked in reverse from Thursday, we have, between 100 to 140 is 40% greater. So some of you that might be comfortable from price changes, right? If we start with 100, we add 40%, we're going up to 140. So that will be our Thursday there, which is C. So some of you got that, very good. Or if we do it with the pure math here, I was just showing kind of the back solving from the answer choices. But we could just divide by the 1.4, pretty easy enough here. And we're going to get 100. So let me know any questions as we go, and I'll definitely slow down. So we got a bit of a harder one here. But there's a very important concept or habit, which is we do have the calculator, so use it if you need it. But as we get stronger and stronger in quant in our mental math, we do want to get to where we use it minimally, ideally, because we can round on a lot of the problems. There's several clues that we can round. So may say approximately nearest to or closest to in the wording, in the stem. When I say the stem, that's the most important part, is what exactly is it asking for. And another clue is the answer choices are spread far apart. So we'll see both here as we look at this. We see like the values on the graph are just maybe a little bit off of a round number. So that, for instance, we could round to 6 for this price here. We also notice here it says approximately. And we also see the answer choices are pretty spread out, like almost 0, 1 something, 2, 4, and on almost 6. So you see here, price per pound. So this is really important. The word per means divide. So we need, this is something that people are very often mixing up, is price, we need per pounds, dollars divided by pounds, all right, at store B. So let's just start with that for B. Dollars over pounds, we have, it's about 6. So we'll just say 6 here. And then we're going to check the weight of the package. So as always, we want to make sure we're understanding the axes here. We got price here, pounds here. So dollars over pounds, we got 0.6. It's slightly off here, maybe, but it's close enough. And then we're going to 6 over 0.6, we get 10. All right. And then for D, this one's a little bit harder. We have 4.5 here is on the graph here. And then here we have 1.1 right between the 1 and the 1.2. And I would just estimate this. The better you get with number sense, you might see it's taking away around 10%, around 9% it's taking away. So if we take away around 10%, it's going to go to around 4. But I will show the math a little bit closer. So this would be 11 over 10 on the bottom. If we're dividing by 11 over 10, that means we're multiplying by 10 over 11. I just like to rewrite it like that, cross it off. There's different ways to do it, but I like to just cross things off. And then times 10 over 11. It's taking away around 1/11th, which you'll learn is about 9%. That's why I say about 10%. And so then we're going to get around 4. You could also calculator it too, but as you get better with the number sense, again, this gets faster. And then it says, then we read carefully again, is greater than So how much greater than? That means we're finding the difference between them. We'll do the 10 minus the 4, and we get about 6. And so we have that 580 there. Now I'm going to have you try the second one. I will give one hint, is you may be tempted when I just showed you something. I often see that people do it automatically the same way. You could do this exact same way where we're finding the price per pound, but it's actually faster if we solve directly. It's saying how many pounds could we get for $73? So you may, instead of getting it per pound, you may just think of it in terms of per package. Because the numbers work out really nicely here. We see C is right about 7. So with that hint in mind, let's give that a try. And basically the hint was we might not want to convert it to per pound. We might just leave it in per package. So I'll get the timer going here. All right, looks like people were pretty quick, but there was a trap here where you do have to convert it into pounds at the end. If we're going to count the packages, so it's possible my hint was misinterpreted a little bit, but there is a final step here. If we do count it in packages, we're still going to have to convert it into pounds at the end. So one way or the other, you do have to convert it, but it's just easier to do it at the end than at the start. So pounds of walnuts for $73. A bunch of people chose this 10, which is actually the number of packages, because we have $73 dividing by $7 per package, right? Around $7 per package. If we do that, we're going to get the units in packages. So I think about half of the people got this 10 answer, 10, but the units were packages. And then again, the most important habit is reading exactly what it's asking for, double checking that. We might write it at the start and at the end, but definitely one or the other or both. Probably ideally both, as we're looking for pounds. And double checking pounds at the end. We had 10 packages. We still need to convert it. So we have 10 packages, and then we have 1.4 pounds per package. So 10 packages times the 1.4 pounds per packages. And then we're going to get the 14. So I circled this. That's actually the trap answer. And our correct answer here is going to be that 14. So let me know if any questions on that. That one's definitely a bit harder. So here's another one I'll show for approximation. We see the word approximately again, 100,000 miles from Earth. So this one's a bit easier. We just have to read the graph. A lot of them actually will be, this level of simple. There's definitely a bunch of tricky ones too, but you can get stuff like this where it's just a matter of reading correctly. So 100,000 miles from Earth here, we check that. It's right at a little over 40 minutes. It asks how many minutes, and that's our answer. So sometimes, we do have to be, like I said, vigilant, but sometimes it's that simple. And then this next one, we have average speed. So average speed is going to be distance total divided by time total. All right. So average speed during the first 1.5 hours. Here we have a unit conversion. So again, we are going to need a lot of the fundamental skills. They're not necessarily always going to be that super advanced, but we do need all the fundamental a lot of the fundamental skills from Quant for this. So we have 1.5 hours times 60 hours times 60 minutes per hour. Going to be 90 minutes. So we'll look on the graph here at 90. All right, it's right about here, 425. Now, our trap answer, though, would be this 425 because it said average speed. We do have to plug it back into this formula. This was our distance total. We still have to divide by the t total. So we have the 90 minutes is our t total on the bottom. And it's per hour. So we're actually back to 1.5 hours. The 90 minutes was just to read the graph. 425 divided by the 1.5. Then we can just glance at the answer choices. Before using the calculator, it's clearly not any of these low ones. And it's clearly not the 425. It has to be the 285. And that's our answer. Let me know if any questions so far. So super important to just seek out the specific details we need. This is even more so true there can be a lot of this on graphics, even more so true on multi-source reasoning where like this whole page would be full of info. But over 90% of the info probably most of the time we won't need. So here, suppose it asks for average temperature in Texas for June. We're going to want to, right, we see the months, we see June, we see Texas. We focus on only that number, which is 90, and ignore everything else. So that's really important. Now, there are sometimes details we may need to be more aware of is essentially there'll be some sort of a trap where this is talking about percentage of sales versus total sales. So there can be details like that in terms of reading the axes, but we do want to block out all the unnecessary info. So on that note, yeah, the passage will often include important clarifying details. It'll also often restate info that we already see in the graph. And it might even include some extra info that we don't need. So here, this might look a little unusual at first. So we might have an instinct that what's going on in the graph, what are these numbers on top? That's kind of unusual. Well, it kind of seems like they line up with the graph on the left. So maybe just helping us read the graph better. If we read here, it does explain it, right, in more detail. So whenever you have a doubt, you do want to read more carefully what it's explaining. Number of calls made is indicated above the blue bars, and it gives an example. Okay, and then this first sentence is just restating, which is very common, what it says in the title. Number of calls made by the call center during a 41-day period. We don't necessarily care that it's outside, right? But it's number of calls made during the 41 days. And that it says that in the graph already. And then median. So the word median here, super important. I like to use this formula, n plus 1 over 2 the term. So essentially, what that means is if we had 41 calls, or let's just do a simple first. So say you had 5, right? We just take 5 plus 1 over 2 is going to be the third, right? I guess 3 is with RD, but the third term. And that's easy to see visually that it's in the middle. If we have 6, then this just does take a little explanation. When I say the, say with this one, if we get 6 plus 1 over 2, we get the 3.5 the. Like that doesn't actually exist. That's just that formula is to show that it's in between the third and the fourth term. So that's going to be right here in between the third and the fourth. And so the way this formula works is just to show you that it's in between the third and the fourth. So here, like if we had the numbers 5 and 7, let's just make this a little clearer. 1, 2, 5, 7, 10, 14. We're looking, if there's an even number of terms, it's going to be in between the middle two terms. What this 3.5 means is that we're taking the average in between these 5 and the 7. So you could just visualize it on a number line. What I prefer is right in between the 5 and the 7 is a 6, halfway in between them. Or you can formally do it, 5 plus 7 over 2 equals 6. So either way there. Back to our problem here. And one nice thing about the data insights is you do get a lot of review of a lot of the different topics, so that can make it more fun. If some of you are saying, oh, this is kind of a pain, it's not that much fun, encourage everyone to get into the mindset as much as you can of making it a game, making it as fun as possible. Just that little side note of it really does help to celebrate your little wins and try to overcome the inevitable frustrations of making mistakes and stuff. But just like, give yourself your pep talks. That mindset's super important. But anyway, here we got the 41-day period. So 41 plus 1 over 2. So we got 42 over 2. Yep. And then we get 21st term. I guess it's ST again, but yeah, the 21st term. And yeah, so we would have, for the 21st term is going to be 32, and our answer there is 32. And yeah, there's also, this is the way I like to do it, is the n plus 1. Somebody asked about, can you use n over 2, n plus 2 over 2? Yeah, that totally works as well. That's actually what is taught in the course. I just prefer the n plus 1 over 2 personally, but yeah, that formula there that they asked about, n over 2 would be the bottom term, the bottom of the middle. And then the n plus 2 over 2 would be the top of the middle. Yeah, exactly. Yeah, that totally works when the number of series is even. Yeah. All right, so this is the one I was referring to where the accuracy is only 34%, even though it really is just a matter of reading correctly and counting. So I'll try the first part and then just see how well you count correctly in the second part, but I'll show you what I mean. So how many months in which the East Division's revenue was less than $5 million. So we're just going to check less than 5. We read the 5. Okay. We have to read. Yeah, we skipped. Somebody asked, by the way, we did skip the second part of the last question. Yeah. We're just trying to cover as much as we can. So yeah. So yeah, sorry. This is 5 here. All right, we're going to count how many are below that. It's true you can't draw on here, so that makes it a little easier, but this is to show you. So we got less than 5. 1, 2. We got to make sure that this, I think sometimes miss this one because it's not jagged, but 3, 4, 5. This one's a little bit above, so this one's no. And then we got one more here that's a little bit below the 5. Yeah, we see the 5 is here and it's a little bit below. So we have 1, 2, 3, 4, 5, 6. So just have you try that next one, see how you do. It's on the right there. Yeah, really good. And we can see here, like in the data, most people are getting this when I like tell you to be super careful about counting. So I think a lot of the accuracy lower is people just not paying attention closely. So there is the positive of that is really, right, it is a competitive test. The reality is that it's based on percentile. So you want to get your advantage wherever you can. With that in one other side note on mindset is, don't compare to everyone else's timeline on how fast they got their score or whatever, right? It is your own journey. But in the end, right, we're trying to get whatever edge we can by, being more precise. So yeah, very good. 6. So we have 1 there. above. East, we're checking here. East, 1, being really careful, yeah, with the colors. 2, 3, 4, 5, 6. So good job there. And there was one more question here. By practicing more DI questions helps us increase the speed on accuracy. Both. Yeah, I'm not sure if you mean both verbal and quant. I mean, definitely practicing helps you increase the speed and accuracy. Usually the way we teach it with TTP is, we are jumping right to graphs here because we thought people would be interested in getting a good overview. But the way it's taught in the course, and some of you may be at different levels, is normally to do it last after getting the other skills first. But it would be okay to mix some in, depending on your level. If you are comfortable with more of this kind of ratio, some percents, some of the, you don't need necessarily the most hardcore stuff. Well, some of it, the two-part analysis can get a bit more tricky on the harder questions. But just like for graphs like this, it's more of the basics. So definitely with practice, it gets a lot faster for sure. Yep. Yeah. Because a lot of it is like just reading the graph, and it can be done a lot faster. Someone asks, would it be wise to select DI as the last segment? It's very dependent on the person. I actually like to do DI first. So one thing that a lot of people don't know is that it is section adaptive, meaning and officially GMAT says slightly. It's unknown exactly how much. But if you do well on one section, the next section will start off harder. I prefer to do the DI first. I'm pretty advanced, so I am trying for that perfect score. And I'd rather the DI has more variety in what it can ask. So I like to have that first, where the questions are most likely slightly easier by doing it first rather than doing it later once I've already done well in the other sections. And a lot of times people do find the DI hardest accuracy-wise. Now, the flip side of that is if you get easier questions, each question hurts you more. So it doesn't always help you to have easier questions. So that can balance itself out. But I'd say the order, it's actually more based on your personal preference of like your attention and just what feels most comfortable. So for the old version of the exam, I was more comfortable on quant. I preferred to do it when I was more tired and do the verbal first when I was less tired. I've actually switched on this. I've gotten more comfortable with verbal now. I like to do data insights first now because that has the most variety and requires a pretty high attention to detail and also potentially more time pressure. I like to do it when I'm freshest. So I think thinking about when you're freshest relative to the 3 sections, there's also the issue of the break is that you don't have a break. Well, you only have one break. So I like to take mine after 2 sections. Yeah. So I like to take my break after 2 sections. Sorry, I just saw some more questions come in. So therefore, I like to do quant second when I'm a bit tired, maybe potentially a little tired from that first section. And then the verbal last after my 10-minute break. Yeah, and there's a whole bunch of questions about section adaptive. So there was some debate on GMAT Club about what does section adaptive mean, and some people getting confused about that. There is a YouTube video where an executive at a high-level person at GMAT did say that it will adjust slightly to be harder, give you harder questions if you did well on the earlier sections. So however that's defined as section adaptive, I call that both question adaptive and section adaptive based on my definition of it just starts at a higher point or lower point. But officially it's slightly, and we don't have good data on exactly what that means. Yeah. The sections have equal weight, and basically three raw points will translate to 20 points on your overall score. So essentially each 1 point, like let's say we went from increased our score from an 80 to an 86. That's up 6 points. So every 3 would be worth 20. So if you went from an 80 to an 86, that's going to increase you 20 for the first 3 points, 20 for the next 3 points. And that's the same across all the sections. Yep. So yeah, I guess in summary, I said a lot of stuff there, but do what's most comfortable to you, test it out. And the most important thing is your attention to detail, your focus, your ability to get it dialed in for that section. And when I said about something about getting a little tired, you don't really want to think that way. I'm just being frank about it. You want to like kind of have more the attitude that like you can't tire me out, like But there may be a little bit reality of like a little bit of into that second section or third section, a little bit of tiredness. But you do want to build that stamina to where it's much less of a factor. Yeah, and you do want to rest very well, have everything dialed in, minimize alcohol, maximize sleep, all those things, taking care of yourself, nutrition. So all those kind of things are so important. Mindfulness, it's often recommended a good minimum effective dose is like 8 minutes per day. Just the big thing is your belly breathing out in the belly. So practice that. And let's see, a couple other questions here. Calculator. Yeah, calculator can be nice if the options are very close. Yep. Let's see. Yeah, someone asked, is the available question bank and TTP for DI enough? It all depends on the person. You can totally, as often a good idea to, if you want more practice, the official guide is great. There's like 17 questions, 100 questions additional in the bundle. I think it's actually not all DI, but there's an additional, I think, it's like 250, I think, in the bundle, around that. So there's a lot in the TTP. And then if you want more, you can also supplement with the official guides is great. And then I do generally recommend the 6 practice tests are very good. Does tend to be good to invest in those. There's the 2 free, and then 4 more can be bought and retaken. And I prefer to do my worst section first. Yeah, so I like to do my worst section first when I have the most attention. It is a personal preference. And then OG 2024, I don't think we have details yet. I think it should come out in about 10 days. I think the 29th. So there are probably some new questions. The last OG didn't really add many new questions. It was just like 11. I am hoping there's more of the verbal data sufficiency because there is a few of those on the actual test. But yeah, a book on mentality. There was one called Beyond the Content. Logan is another awesome teacher for TTP. He wrote one Beyond the Content that's really good. That's like mindfulness. It's only about 100 pages. So, and then the other one I mentioned is mental toughness training for sports. There's one that's like actually business focused that I actually have. That's like mentally tough for business. And then let's see, what was the other question? Mentality. There's another podcast, Finding Mastery, that's really good too. Yeah, I like that one a lot. All right, let's keep going here on the. I love those questions. Let's keep going though on some of this. So yeah, it's super important to just be really careful about, reading the legend correctly, not mixing up the colors, not mixing up like the different parts of the axis, right? Fourth quarter, third quarter, that attention to detail here, being aware these are percentages, not actual numbers. It is possible as well for the scale to not start at 0 or for it to be like, it's pretty rare, but it can happen where it's like goes like 10, and then the next check is like 100 and then 1,000. It's multiplying. So you do have to be careful. Yeah, so let's see. I'll put in the chat. There's mentally tough. That is, look, I think it's, I hope I'm spelling this right. It's a guy who wrote, and then there was Beyond the Content. That's by, yeah, that's Logan, who's also teaches at TTP. I think it's Logan Tom. Yeah, let me double check that. Oh, let me grab the link actually. That's better. I think one sec here. All right, yeah, this one's awesome. This is Logan Thompson. Yep. And then there was, yeah, this one's a little bit older, but I love this. I'm reading it, been reading it recently. Um, that's mentally tough. Yeah, that's really good. And let's see. There's this one other thing I like that's, one sec, this other little mini article. It's like a 90-second mental workout. I'm going to pull up that article as well. Yeah, this is pretty cool. So here's a few. Yeah, I'm glad you had those questions about the mindset stuff. It's really important. So let's get back to the graphs though. So yeah, I was just saying that you do have to be careful about the axes. A more common one is percent versus actual number. So a common one is mixing up like price, let's see, revenue, yeah, price times quantity equals revenue. So this is in dollars. Price is in dollars per unit. So we've got to be really careful not to mix up, like if it said the price, right, we'd have to multiply by the quantity times units to get dollars. So a lot of times people will put the wrong units. We got to make sure if this is dollars here, we don't just have dollars per unit on the other side. We're going to need to be multiplying by number of units. So yeah, super important. Again, here, just being really careful with the colors, right? So state, county, city, and then, you know, not mixing up which state it's in. Also, sometimes on these line ones, you also have a shape. So that gives you both a color and a shape. So that can, you know, make it easier. Your thinking's telling yourself, okay, purple square, you know, and double checking that. Really easy to mix up. All right, so this one, let's just have you try quickly on the left. The median, right, is going to be the value in the middle. So just being careful there with the colors. All right. Yeah, so a bunch of people are saying C30. Yeah, so let's go through this. So Charles, we got the triangle here. We're looking at only, got to be really careful, only these 5 data points. So essentially we're looking for the middle of them. So we're going to essentially, we could start either from the top or the bottom and count 3 away. So not this one. These are the 2 bottom ones. It's going to be third from the bottom or third from the top, not the 2 top ones. So we are looking at this value here. So we see this is 30 and we got 30 here. So very good. And this next one, hopefully can be done extremely quickly because, well, a trap would be, a lot of times we don't actually have to do a calculation. It's saying average daily revenue for the 5 days was smallest 4. Average technically is the total divided by the 5 days, but we can see here on the graph, we don't actually have to calculate the totals. We see one of the lines is way below. So the total is going to also have to be way below. We see here this line is way below everything else. We don't actually have to do any calculation at all. We just check here. We see the black and we see Scotty. So that's the type of skills will save you a lot of time. And like, we don't always have to do the exact calculation. Yeah, and there was one other side question about the data sufficiency verbal. There's only like 11 of them. They're on the in the current book. It's under the data sufficiency hard in the online question bank only. Data sufficiency hard, out of the 43, there'll be 11 that are more of this verbal based. We are hoping though, the new book that comes out in like 10 days, there'll be more. All right, so this is kind of a potential shortcut. I'll just show this bottom example. It's okay if you haven't seen this. I don't think they teach it quite exactly this way in the TTP, but this is a LiveTeach demo, and I do like to add some additional time savers. They are potentially optional, but a lot of students do like me adding kind of some of my own secret sauce and different things that are nice time savers. So first two scores, this is called residuals. So if you have two scores that were 86 and 87, and the average is going to be 90, then essentially we can think about it this way. So we take the 86, we take the 87, and then we have an X, and the total below the average and the total above the average have to be equal. They have to balance each other out. So essentially the amount below and the amount above have to balance each other out. So here we have -4 from 90 versus the 90. We have -4. Here we have -3. So combined here, we have a -7. So to overcome that, we're going to need to have the negative and the positive balance each other out. So we're going to need to be +7 versus the 90. So this one's going to have to be, the X is going to have to equal 97. And actually, I will do the top one to just do one more example. Definitely let me know if this makes sense or not, or if more questions on it. This will, I believe, most likely be going to YouTube if you do want to rewatch later. But you are live, so thanks for coming live, and you do get to answer your questions. Mary scored 80 on the one test and 100 on X additional tests. So we have one score of 80 relative to the 95. That's going to be -15. And then we're going to have 3 more values of 100. Or sorry, we're going to need, well, I just gave the answer, but we're going to, I didn't mean that. We're going to need to write how many hundreds are there. So this one would be +5 versus the 95. And I do go into more detail on this with the teeter-totter diagram in the course. We don't have really time to go into all that today, but here's just another way to kind of sketch it out, just so you can kind of see it here. This is +5, this is +5, this is +5. So then these cancel out. -15 here. We're going to need +5, +5, +5 to have that cancel out. So we're going to need 3. What is X? How many additional tests at 100? We have 3 of them. Yeah, and someone asked, is that allegation? Yeah, we don't use that term in the course, but that's correct. Yeah, exactly. Yep. So let's just do the one on the right for now. Actually, no, let's do the residuals first, and then we'll come back to this. So let's see here. All right, so here it's asking, is the median time was blank greater than, less than, or equal to the average time? All right, so first we're going to find the median. So here we have greater than, less than, equal to, and we're going to look at these 5. We want the median, so we're going to eliminate the bottom 2 and the top 2. We're looking for the third out of the 5. So essentially, like I showed on the other one, we want not the top 2, not the bottom 2, but the one in the middle. That's going to be E. So we're looking at that. Now, potentially, if we're comparing to the average, we could just take all the numbers, use our calculator, and divide. I'm also going to show you the residuals method. Essentially, on that last problem, suppose instead we had 86, 87, and 100 instead of 97. This would pull the average up. So now our average is going to be greater than the 90 because the amount below the average, we have +10. And then between these combined, we have -7. So essentially, one way to think about this problem is the amount above that median more than the amount below? So let's look at it. And the other trick here that can be a slight time saver is just counting the number of bars instead of the exact units. So instead of reading like it's all to scale here, as long as it's to scale, we could count the bars. So we have minus 1.5 bars here relative to this. This is here plus 2 bars. Here, this one here is plus 0.5 bars. And then this one here, relative to here, it's minus, here, between here and here, it's minus 1 bar. So this distance here was 0.5 plus 2. Let's make that a little clearer. So this one is minus 1 plus 2 plus 0.5. And so we see, let's count how much overall is above and below. We have minus 1.5, minus 1, minus 2.5. And here we have plus 2 and plus 0.5. We have plus 2.5. And overall, we get 0 residual. So there's 0 above, 0 below. When we look at everything, the amount below is the same as the amount above. Therefore, our average will be exactly equal to that E. So essentially, if we got a positive residual, it would pull the average above that E. It's most maybe easy to imagine like the example of the test scores, right? If you had a bunch of 90 scores, right, and then you suddenly get an 100, it's going to pull it above. So essentially here we see the 0 residual, so our answer is going to be equal to the amount below this value at the top here in yellow was equal to the amount below. And then one more thing here on the right that comes up a decent amount is we have the word range. All right, it's talking about the range doubles. So you'll learn that in statistics. We got max minus min. That's going to double. So let's look at what the original value is. We're adding a 6 machine. We start off, we have a range here. Our max is 65. Our min is 30. So let's look at our range here is between those 35. All right. And the range is going to double. So theoretically, if the numbers were different, it could range and have a value below, but you can't have a negative number here. Plus, the answer choices are all bigger. So, potentially if it's a data sufficiency and the numbers were bigger, it could go below it or above. But here, it's going to have to be above. We're going to go another plus 35 here, above this 65, and then we just add carefully, and we're going to get 100 here. All right. There was one question on the residuals on the prior thing, so I just want to clear that up. Someone thought that you could also have X be 5. Well, it tells us for sure the average overall score was 95 on this first one. So you can't have, there's only going to be one answer. To have a mixture, if we had 5, X is 5, there might be mixing up this plus 5 versus the X being 5, but essentially the total amount above and the total amount below have to be equal. So if we had 5 times 100, 5 hundredths, if we wrote this out, here we'd have another 2 hundredths. Our amount above the average would be plus 25. And our amount below the average would still be, with this 80, we had minus 15. It would pull the average above the 85. So it tells us the average score, overall average was 95. That's a fact. So therefore, we're going to need only 3. Yeah, so that the amount below and the amount above is the same. And there was one other side question about advice on admissions consulting, and that was a recent addition to TTP. So yeah, definitely take a look at that. Yep, they have some really great people. So this is an important one here on the right. We'll skip the one on the left for now, just so we can cover more. But percent change, super important. And again, we can use our estimation here. So births on Sunday would have to be increased by blank in order to equal the number of births on Tuesday. So we're looking at, we want to increase from Sunday to Tuesday. So essentially your formula is new minus old. The old is going to be your baseline. So the old is your baseline. Over the old is your percent change. So here our new is around 13,500. That's where we're going up from. Essentially your baseline, we want to increase from this to go to this. So your baseline is going to be this old on the bottom. A super common trap is to mix it up and put the new on the bottom. So that's really, really important. See that trap a lot. It's these kind of things. Anything that can be backwards, you want to double check. So our old was this 7,500 here. Potentially you can see if we doubled it, if we had 100% increase, this would have to go up from 7,500 to 15,000. So potentially without even doing the math, we can see it's significantly below that because it's only 13,500. So it's going to have to be the 80%. So that can definitely help. And let's see. Yeah, if you were to do it formally, if we plug it in here, we got the 13,500 minus the 7,500 over the 7,500. And then we're going to get 6,000 over the 7,500. You would chop off the two zeros, right? Cross them off at the end. And then we have divide by 15 on the top and the bottom. We'd get 4 over 5. Yeah, so someone asked, very good question. So an increase in 200%, yeah, some people are saying 2x versus 3x. Yeah, it's 3x. So that's super important. That's another super common trap. Yeah, is that this 200% would be 3x. So what our formula is a lot of times people are mixing up 200% of something. So let's just look at a couple examples. 200% of 10 equals 2 times 10 equals 20. Yep. And then if we said, looks like their kind of AI or automatic thing is going on here. And then if we said 200% more than, that's going to be equals 1 plus the 200 over 100. Yep. So it's going to be 3x, yep, times the 10 equals 30. Does that, any questions on that? All right, one other thing is we talked about shortcuts, is sometimes you can just kind of visually compare instead of the exact numbers. If you wanted to be safe, you can use exact numbers too. But a lot of times you can maybe just get a sense of it from the visual comparison. As long as we're careful to check the axis, it starts at 0, it's linear. Then it asks the greatest ratio of men to women. We want to be careful. We're looking for large men relative to women. So we're looking at these bars. Which one's like the most x, most times as big, right? We want men over women. So that's going to be here. And 8 over 2. We wouldn't need the exact numbers, but we can see visually that this is by far the biggest ratio. Maybe our second closest is here, but this isn't even a 2 ratio. This is a 4 ratio. So it would be in this range, the 30 to the 34. So here's another percent. Yeah, well, someone asked, is then that the smallest ratio? So let's make sure. Greatest ratio of men to women. So, and someone asked about frequency tables. We can actually take a look at that. Yeah, I think that would be a good one to look at. Histogram. Or Actually, not the frequency table. That's less common. I don't have an example picked out of that. I do have the histogram, which is more common, but essentially the same concept in graph form. And so just to answer that question about smaller, greatest ratio of men to women is literally this fraction, men over women. So let's actually go through the numbers. So what it would be is men to women. We would say literally 8/2 for this first group. This is equal to 4 is the ratio, right? So yeah, you do want to be really careful to not get it backwards. Our second biggest would be this, which is 9/5, which is 1.8 as the ratio. So yeah, make sure not to get it backwards. Yeah. Yeah, someone asked about, are there webinars yet for MSR and TPA? I'll keep that in mind as a request for next time. I do these around every 2.5 months, usually before each is the current cycle. But potentially, yeah, you'll get an email if there's something before that. But I'll keep that in mind for the next one I do. I usually do it before each LiveTeach session, which are around 2.5, 3 months apart. Let's see. Someone asked about histograms. Yeah, that would be a good thing to look at. So, or at least maybe they said frequency table, but it's the same thing in graph form. So actually, let's go back one slide. Histogram, a frequency table would just be table format for essentially this, but the histogram is, you have these ranges at the bottom, and then essentially the frequency in this axis. So yeah, like if this was in table form, you would have like 10 to 19 has 0 people frequency, and this is age. If we had it in table form, and then like the 20 to 29 would have here we see 3 people, right? And 30 to 39, a little messy here. 30 to 39, we have 5 people. Yep. And so on. So let's try this next one. It's a great example of where reading, again, is super carefully the stem. Again, when I might have meant to say earlier, when I say stem, I mean the question part. So here you have this if part that a lot of people, if they're rushing, they're not reading carefully. Sometimes, there will be extraneous info here, but usually in the question itself, that's by far the most important thing. There can be very useful info in the up here as well. Like here we see it tells us there's 60 students, so we don't have to count them. But like the histogram, this part here is kind of, we should know that a histogram shows the number of scores just from right frequency, right, looking at it itself. But here we see if a score is less than 40, so we're ignoring all the ones over 40. So that's the key thing here. Ignore the data we don't need. Number one of in the top 2 skills probably on data insights. I said earlier, number 1 was reading the question carefully. Number 2 is only using the data we need and pulling that data correctly. So we're focused on these 4. It says probability the score is greater than 19. So greater than 19 would only be in these 2 ranges. And then for probability, we're looking for desired divided by total. So probability equals desired divided by total. So, okay, so we have desired is in these 2 ranges here. We've got 5 in this range. We got 7 in this range. So our desired over total. We got 12 in the desired. Then we have 12 here. We need to count the rest. So we have 5 here. We've got 3 here. So that's another 8. So we have 12 over 12 plus 8. We got 12 over 20, which is going to be 6 over 10, which is that 0.6 there. Let's see. Someone asked fastest way to get average in a histogram. It's actually going to be kind of a pain here. Yeah, you'd actually have to find the totals for each thing. So I think it's less common that you'd have that. Like I think the amount of calculation that you'd have to do would be less common here to have to do that many calculations. But for this one, yeah, you would actually have to take three. Well, you couldn't actually find the average because they're in ranges. So it's possible like you could have a weighted average. Like let's say this just said 9, this just said 19 if it wasn't a histogram. Or let's just say you could have a graph like this. Say it had none of these data. It only had 3 bars. Maybe it was talking about just part of the graph. What was the average? And suppose it said it wasn't 0 to 9, it was just 10, 0, 10, and 20. Then you would have 3 times 0 plus 5 times the 10 plus 5 times the 20 would be your full total. You take the full total of that, you add that all up, and then we would divide by the total. It's like a weighted average, where we would divide it by the total number here that we had 3 plus 5 plus 5. So we would take that and divide by 13. 13 total here, 13 total. So weighted average, you take the total number for the value and divide by the total number of units. So it'd be, average equals the sum over number. Someone asked about, we have to stop soon here, but someone did ask about stacked bars. So let's do one real quick. One sec here. All right, stacked bar. Yeah, I do have one here. We will go a little over. But yeah, I love all the questions, so thank you. Okay, so we got 4 factories. So essentially here, the stacked bar is just saying for the factory A, you have essentially here 15 line workers. You've got 5 here, maintenance, and we've got 5 here of managers. Yeah. So for this first part, again, reading super carefully, 1 employee were randomly selected from the 135 employees, and the selected employee were a line worker, okay? So it's kind of like that if one, we're only selecting, we're only looking at the line workers, we're completely ignoring everything else. We ignore this, ignore this, ignore this, ignore this. So it's saying we're only picking from the line workers. Then we're saying is most likely works at, essentially being what's the highest probability. The total is going to be the same for all of them, or all of them combined. But essentially now we don't actually have to do the numbers. We can just look visually. Everything's starting at 0. Which one has the most line workers will have the highest probability. And then we just have factory B there. And then this next part, which had the highest proportion of maintenance workers. So here, proportion, it means fraction. The word proportion just means fraction. So it essentially means maintenance over total within that category. So you can potentially look visually. It is a little bit close, like which one looks like the biggest fraction of maintenance workers. We're looking at the red. Looks like either between this one or this one. It looks like the C actually has more total, but relative to the entire shape, it probably looks like D if we had to choose really quick. We might want to count though. We can count the number of bars instead of the actual number. We've got 3 here, 3 bars out of 5. So this is 3 bars out of 5 total bars. 3 out of 5, all right, is like 60%. Or you can either think of it as a fraction or percentage. Here we have about 4 bars. 4 out of 9 bars is about 40, a little bit, about not quite exact, but around 44%. And it is like 9 1/3 bars, but close enough. Why would we consider the total worker? Why wouldn't we consider the total workers? Yeah, so this is tricky for the first question. And let me know if that second question made sense. So just to clarify, this was factory D, because we had 60% here, a bigger fraction, and here we had like 44%. And then these ones are much, much smaller. We're not going to really check. the question was, why don't we choose from all of them? Yeah. So if this was crossed out here, we would choose from all of them. Yep. And then it would just be factory C because there's the most people in that. However, with this, it's adding more info. We're randomly selected from those. It's actually specifying only the 130, not all the 135 employees. It says selected from only select only the ones that were a line worker. So that wording's a little tricky, but it's saying we're only picking out of the ones that were line workers. So yeah, so we're ignoring this, this, and this. Because of that wording, you do have to get comfortable with that wording, but we're only picking from the line workers. Then we're then the best probability of that. With all the workers, then the shortcut is just, well, now we're looking at all the workers. They're most likely to have worked at C because we're just looking for the most out of the total. Yeah, so it tells us the total is 135. It actually doesn't really matter what that total is because, right, the one that has the most workers would have to be the highest probability. Someone asked about recording. Yeah, this should be, I expect it to be going onto YouTube, so I hope you enjoy it there. Please share, like, comment, all that stuff that we love, so thank you. And oh, someone asked about, yeah, I can't, it's hard for me to stop. Technically, I'm supposed to stop, but thank you, guys have so much questions. There was a question on the earlier one we did what the answer was. Yeah, this was very good. Someone asked, was it 86? It is. I'll show it really quick. And the second one, yeah, of each score, which could be the median. So this one, to find the median, we have to find the 30.5th value, or essentially, as someone said earlier, the 60 over 2 would be the bottom of the range. So 60 plus 1 over 2 th. So 30.5 the term, meaning between the 30th and the 30. Essentially, if we have 30 values here, right, here's the 30th, here's the 31st. Sorry about my writing there a little bit quickly, but it's right in between. So then we have to count. It does take a little bit of extra time on here, but we have 3 here, plus another 5, we got 8, plus another 5, 13, plus another 7, we got 20. Here we got 25. And then here in this bar, the top of this bar, we're going to have 32, 32. Essentially, this is this column is going to have the 26th through the 32nd term, right? Because these first 5 ranges were 25 terms. Or sorry, yeah, 26th through 32nd. Yep. Yeah, so the 30, between the 30 and the 31st will fall within this range. And then if we add 30 to it, we're going to end up with 86. So someone did that on their own. Very, very good. Yeah. And let's see. Someone asked, is the probability total or per factory? It just says which is most likely on that other one. Yeah, so most likely out of all of them. So the actual math on it, I will show. You wouldn't necessarily need to do it, but here, the actual math, if it were line workers, again, we're ignoring, well, let's just suppose actually not just line workers because it's a little easier with the numbers. So here, we're just going to take here, this 45, whatever. It would technically, this probability would be like 47 out of the 135, desired over total. Yeah, and that's going to have to be higher than for this one. This is for C. For B, it's going to be like 38 over whatever, 37 over the 135. Yeah. So yeah, that's a good stopping point. Thanks so much for the questions. I'll drop the link one more time. I think some people came in a couple minutes late, but I am teaching a LiveTeach. If you liked what you saw today, that will be starting in, let's see, 10 days, Wednesday the 29th. So that's Mondays and Wednesdays at 8 p.m. Eastern. Yeah, so It's 40 hours, so we'll cover over 10 weeks. And yeah, hope to see everyone around. Let's see, put that in the chat here. So yeah, thanks everyone. Best wishes with your prep. I'm sure you'll do great if you put in, have the right system with getting expert help and training hard. So yeah, everyone have a great day and a great journey. Thanks a lot. Bye-bye.